Morning, Kishan.
Morning, Floris.
So today we have an article from a software engineer at Sony Sports. Lewis, the author of the article, actually exists, so it's not an AI generated thing, hopefully. It is about how software architecture is changing in relation to the use of AI. The author argues that how architecture used to exist was to coordinate humans, but inherently humans are slow and expensive. So the architecture puts guardrails on what they build. Now AI comes, removes the cost or part of the cost of writing code, and architecture stops being sort of a blueprint for construction, but more a regulator of change. So that's his argument, not mine. And he says, what I find interesting is he says the architecture goes from being the dictator to being the regulator. And engineers shift from building to controlling. He has some images also in his article, which are simplistic, but it gives a picture of what how he thinks things change. First, let's look at it from a positive angle. What do you think about the article, and what's right in the article? What do you like?
Well, the article, I think it's an okay article. It has some premises that I agree with, in the sense that architecture is built for humans to interact with, or not interact with, to have an idea about how to build software that other humans can collaborate on. It gives us a set of rules, a set of boundaries to build upon. I don't really agree with that it's just for humans. I mean, the whole architecture definition here gets really broad in the latter part of the article, where a lot of things such as rules and guidelines and the way we build is also being put under the architecture umbrella, which I don't really think is architecture. But that's a definition thing. It doesn't really matter. Like it says here, it says architecture becomes a set of constraints, but I don't really think that's valid. It's two different things. Architecture is more a design. In my opinion, architecture is more of a design on how to color in between the lines that you put out in the architecture. And the constraints are the actual definitions of what to adhere to. Architecture doesn't really give you any constraints except for the the foundation on what to build upon. So I'm not 100% agreeing with the article. That's basically what it boils down to.
Can you for me as a non-engineer, I see architecture almost similar to like when building a house. Obviously,
Mhm.
we discussed this example a couple of times already. Like building a house, not the same as building an application, but when you hire an architect to design your house, you have sort of a blueprint, right? And it says it gives the idea to the contractor to they know then what to build, what to and the homeowner knows what to expect when it is delivered. Similar, perhaps, with software, as an architect goes and designs an application. And obviously, you probably are going to correct me in some ways here. But I was wondering what he then. I couldn't really understand what he meant with architecture goes from being the dictator to being the regulator. What do you think he means by that?
I'm not exactly sure what he means by that, but what I read from it is that it goes from being the one that sets the rules to the one that basically, not that sets the rules. The humans interpret an architecture and build around it, right? Humans are able to interpret things and get ideas from an architecture and how to build upon that. But since AI needs better constraints, it needs to regulate how to build things. So the architecture, in the normal sense, if we set out an architecture for a new system, a schematic, and some rules around that on how, not how to build it, but what to build inside of that schematic. So let's say modules, components, and the interaction between those. For example, if we set out a microservice architecture right now, it would be a schematic of the different services and what the services do, what they're responsible for, and how they would communicate in a diagram. That would basically be the architecture for a system that has a few microservices. And the components inside of that architecture would probably be, I don't know, an event bus or some caching system and some components that you put in to regulate parts of the microservices. For an AI, I think what he means is that for an AI that is too broad, it's not only the blueprint that you need, it's also guiding how to build these different components, because in this article, it all becomes about AI native development, right? You're not doing the work, the AI is going to do the work. So to provide them with an architecture that is more than just the blueprint and the schematic on how they interact, it should also be the guidelines that are granular enough on how to build those components and what, for example, what language to use, what communication protocol to use, what the messaging should look like. I think that is what he is trying to define here, is that architecture went from something humans use to communicate and how a system needs to be built without going into deep on what to exactly build in those systems. Architecture for an AI needs to be that plus a whole set of rules and implementation guidelines and regulations on how to build those different components and how to interact with each other.
Which is, I think, ties back to our last conversation about your model, the four-layer model, that
Yeah.
layered model that you made. Is so just thinking about that model, and then in a greenfield approach, that would definitely, opposed to like a brownfield where an application already exists. In a greenfield approach, you can populate the four layers with, I assume, then all kinds of also architecture rules or architectural rules. Can you, from experience, and maybe it's also a bit of like looking into the future, but can you say from experience that your role as you are a software architect yourself, what have you seen? What do you think has already changed in this work, and what is going to change more in a sense of, will there be work that you have been doing on the architecture side that is no longer relevant, and is there work that is added like new as the AI native applications are now going? I think that takes a flight now, the AI native application or AI native built applications. So what changes in the work as from your perspective as a software architect?
So in the experimentation that we have done, I think I write a lot more. I write a lot more higher and lower level implementation rules instead of doing the implementation myself. So what changed there is that the architecture is still the part that we always used to do, right? The schematic part of it, how what the components are, what the landscape looks like, how they interact with each other. That's always what we did. But right now, what we did back then was also, use our knowledge to create that into code and components and systems. But since right now we are not in this AI native experiments, we are not building those things ourselves. We need to write a lot more on how we want the AI to build it. So it's basically the same work what I'm doing, but different in output. Instead of doing the implementation and using my knowledge to know what to write and what components to set up and how to set them up, I'm using my knowledge to write the rules and the guidelines and the basically sketching out and writing out what I would do if I would teach it to somebody else on how to do it.
But then your blueprint would actually have like significantly more detail to it. So it actually
Yes.
gives more constraints or rules and guidance than opposed to it giving less of these, right?
Yes, exactly. And that's kind of what I have a problem with the word architecture that's being used here in this sense. Architecture is always, it has a sense of being a schematic and not much more than that. But architecture in the way that he puts it here, that it should be for an AI, it's a lot more documentation involved and a lot more in depth than just the schematic.
Yeah.
An architect, for example, an architect is not going to tell you what kind of concrete to use or what kind of rebar you should put in. The architect is going to architect the blueprint for the floors, the blueprint for the design of the building, but they're not going to set out materials. What this is going to become is that we also, to use the analogy of the whole building and architecture part that's set in the real world, we also should now give a bill of materials and a set of how to build and what columns to build, for example, in what way, because that's what we want to have control over, a deeper level of the architecture that is more intertwined with the actual implementation. The whole benefit of this is of course once you write it deep enough and have enough levels that you can split project level from actual implementation level, is that you can reuse these set of rules and architectures to build multiple projects in a similar way with similar complexity and
Yeah.
probably have a good enough output that you could use it.
So in a sense, if you work in a direction that is similar in building applications or platforms, then the context that you provide, and each time again, that compounds this information, and that makes sure that you have to write less of the bill of specifications and doing like design work, so to speak, right?
Yeah.
And so now I would say that this article then would be sort of half right, half blind. What is the blind part being? There's a lot of like legacy software out there. Not to repeat ourselves from the last conversation also, but this I assume that if once you have and that's also what we discussed, once you have an architecture and build the product or the platform, the application, then it needs to have, you need to take care of it. You need to build new features, do maintenance, etc. So it changes over time also. This being from a legacy software standpoint, how would this work in the legacy environment, this idea of what you just posed?
As we said before, this is very hard to do without any guidelines in place. You have to write something from scratch. So the only thing legacy or projects normally have is the schematic that is not updated in years. The first idea or maybe the second version, and everything that has evolved afterwards is probably not reflected in the blueprint. So you would need to have a deep dive into the project and to make a status quo of what's there now, what it looks like, and then build on top of that with these documentation layers that give constraints and rules and implementation guidelines for an AI or any other system that needs to work on it. So it's basically doing the exercise from scratch.
I think that maybe to go a bit like to a higher level of like what do you from a legacy or a software modernization perspective, you have different paths to go. Like if you want to modernize, you have like let's say six different ways to modernize a system. One of them being refactoring, another one of being rebuilding completely. I suppose most of these AI native developers or engineers always take the assumption that you do the rebuild, right? And that you have the context, the information, similar to the design first analysis that we did, their platform that also sort of assumes that there is a lot of context available, a lot of information and documentation. So from that perspective, might that be a good idea to just assume that the rebuild is always the best way forward, or is that like let's say 9 out of the 10 cases, because you don't want and maybe let's skip the mainframe like bank things and like the that type of like very difficult mission critical software.
Mhm.
Like in a general sense, would a rebuild now be almost always be better as all these things progress that fast?
No, no, of course not. Rebuilding software is not the problem. It's, as I said before, it's the ecosystem around it. Sometimes there are not things you can rebuild, or the newer versions of software don't integrate with systems that are mission critical. I mean, in our experience, we could rebuild everything that is out there, but it might not necessarily do what it needs to do at that point because it's so integrated or intertwined into either other business software that cannot be changed out or processes that need to work in a certain way or have to adhere to certain regulations. So it's not as simple as just rebuilding an application. Like you can rebuild anything right now. You could always. I mean, everyone could always rebuild something, but it's the integration environment around it that makes things robust, but also hard to upgrade. It's never only the one component. It's a whole set of components that work together that make an environment. It's never just one application that does everything. That doesn't really exist. There's no one thing you can upgrade and then your whole system works better. It starts with the one thing, and then you would need to, take care of other things in the environment as well.
Oh, yeah, I understand. And I think that those cases are also way more interesting to work on because they're from a complexity standpoint, the engineer has actually something to contribute to such a project. So I understood like maybe looking a bit to the future also with the four layered layers of the model that you made. What would be a use case greenfield use case that you're trying to solve? So are you trying to test it currently on a client, or do you have like a hobby project, so to speak, to see what works and what doesn't? Do you have already some insights on or preliminary feedback from what you had to change or what you had to do, which was probably or maybe not expected?
So we first started out with a prototype of a product that we already built, TypeJust. We started out building that AI natively for a specific use case. That worked, but we had a lot of learnings from it because there were a lot of caveats and gotchas that we didn't really realize when we started building it that way. So learning from that, that's why we thought of the four layer model, is that we need to have some sort of balance between what is our perspective on development, which is the lower layers, or the higher layers in this sense. And then the deeper you go, the more project specific it's going to be, because those rules might be different for a different either programming language or environment, or what the system needs to do. But the most important thing I think we learned is that we need to do a lot of trial and error to make sure that we steer these agents in a certain way without us steering them. So in the beginning, it was a lot of trying out a prompt and giving that out to the agents, and then seeing what comes back, and then noting down, okay, what didn't go right, trying to fix that in the prompt or the memory or the set of rules or skills that we have, and then trying again. And that's basically the loop that we are doing, is trying to set out a set of rules that we know are a bit of a gray area in the sense of how an AI agent does things, because they are autonomous up to a certain level, right? They do things in the background, and if they don't have any guidance, they figure out their own guidance just to reach the goal. But reaching the goal is not necessarily what we try to do. We want to reach the goal with a certain set of stage gates that they need to go through. A very simple example is that if I write a test that needs to do a certain thing, they could always just return what the test expects, and then technically the test is valid, and the agent reached its goal because the endpoint did what it needs to do. It returns what the test expects. But that is probably not exactly what we wanted to happen. Maybe it has no integration with one of the tracking systems that we have, or it doesn't send any analytics a certain way. There are always, things stacked on top of just input output that need to happen in the background for us to deliver the full experience. And that is what we are right now testing out in the second iteration for a client, is that, okay, we have the first version and we have built a system, but it took a lot of steering from our side, and re-prompting, re-implementing, and resetting rules. And right now, what we are trying to do is to grab all those things together and layer that, and then I hope to have given the agents enough knowledge so we don't need to keep steering. That there is enough context and enough guidance already delivered to do things the way we want them to be done. And that is what we're testing out right now. It is promising, but there's also still a lot of trial and error, because the more you do these things autonomously by an AI agent, the more things you figure out, okay, it misinterprets things, or we are not sharp enough on some of the rules, or they are too arbitrary.
And it is in this new world of more like the AI native development, is it that you now spend 90% of your time writing regular text, like just prompting and making sure that like, an agent is going into a certain direction, then correcting it, and the other way, on the other hand, also with the instructions from, for example, the architectural point of view, do you write that all in regular text? So is your day-to-day job now, like 4 years ago, it was writing code and doing very difficult integrations and setting up systems. Is it now going towards more like language, natural language?
Well, my job never really was writing code anymore. It was always setting out rules, but then and talking. Instead of writing, I was talking to people and to our colleagues and to developers and to other IT managers in our clients' companies to figure out what we need to do, and to set out the rules that we want to have for this project to build it a certain way. So I was never really doing development anyway. But it did change. Well, it changed for the experiment project right now, that I'm documenting these things a lot more. Instead of having conversations, I'm trying to, not too much, but also not too little, that the things that I want to happen for us as a company that are open for interpretation. A very simple example is that we connect to a specific system for this project, and there are 8 different authentication methods to use to connect to this system we need to use for this project. But I only want to use one way, and I have to specify that somewhere. And I don't want to specify the exact implementation, because then I'm basically doing the implementation in text. I want to be vague enough that the AI agent can interpret it without using too much context, but also not too vague that it might misinterpret what I want. So that's basically the balance, because I can write 50 pages for each of these layers, but that doesn't help us because it's too much context. And the more, as we all know, the more context gets put in, the fuzzier it gets later on in the process.
I think that would be also something that will probably be a difficulty in the near future, is that you have compounded so much information and instructions that you probably also have conflicting instructions and information. But setting that aside, the operator, let's call it the operator of the machine, like the four-layer model, that person does most of his work in natural language.
If you want to, well, the operator of the agent, that's the person that is setting the rules does. So right now, I and another colleague are setting the rules to let the agent work. But the person in control is also probably writing natural language, but then as a set of requirements that the agent needs to fulfill.
Right. Clear. Okay. And what is the mission? So as we saw a while ago discussed OpenClaw, you have now all kinds of different versions of that, or competitors.
Mhm.
Is that Did you use something similar as like the sort of the mission control in the model?
No, no. Right now, we are more focused on getting the output the way we want it instead of building the control of it. I think once we reach a point that the output is good enough from a Greenfield perspective that it can interpret a requirements document, set its goals, and build it the way, not, it's not going to be 100%, but let's say 80% of what's being built is the way we want it to be, then I can look at the control side of things. But before that, I think it's too diving in too deep too soon before we even proven that this can work for us. Because
Right.
I'm not trying to our developers redundant. I'm trying to make them work more efficiently with the tools we have so we can, tackle more important problems, because there's always problems AI can't fix. And that's the thing we are trying to accomplish right now, is that we can focus on the more important things instead of, writing a logging layer, for example, which is also important work, but it's not something that we spend a lot of brain power on. It's more something that we spend implementation power on.
What's the top three of things that AI cannot fix at this point in time?
I'm not sure if I have a top three. I haven't really thought about it that way. I think design is a hard part. All the designs look alike, so it's not the design that is the problem. It's making a unique design, which is the problem. All of the AI design problems, the products look alike, which is also not really a bad thing because most of the things do the same thing. So most dashboards, for example, are all CRUD applications. So the only thing you need to do is to create something, read something, or update something or delete something. That's basically what all admin panels do, or control panels. But they all look alike. They all have the same font. They all have the same spacing. They all have the same conventions. Which is, if you have a user-facing product, if everything looks alike, you're not really making yourself stand out. The second part, making good decisions on the architecture, is of course one of the things that is very difficult because it doesn't have enough context. And if you feed it all the context, you're basically feeding it the architecture, because the architecture that you need to set up are basically all the constraints that you set out. And the box, you're basically filling out all the boxes already, and it's just drawing around it. That's all it's doing right now. And if you ask it for an architecture, it normally chooses things that are easy to set up for an AI, but not necessarily the best choice. For example, if you want to build an application right now, it's if you say, hey, I want to build a web app, it's I think 99% chance that it's going to put you in the Next.js stack, which you might want, might not care about. But that's basically the go-to way of doing things nowadays using AI, all JavaScript, which is fine, but it also has its downsides if you want to do some other more performant things. The third
Third thing,
one,
probably what you are going to mention, is the documentation and the context that is not.
yeah, I think it's not that it cannot do it. It's more that I haven't found a way to reliably let it keep everything up to date without me telling it to keep it up to date. So
Right.
there is a way of updating the documentation and the architecture to keep everything up to date for the project after finishing a task. But if it's a set of tasks, I found that it updates it with the latest thing it has done, but all the other things that came before it, it kind of forgets. And I know that the agent did it, so I'm telling it, hey, why is this and this and this not there in the documentation? A very simple example is we added, I think, 3 endpoints in one of these prototype projects, and I asked them to update the documentation, so we also have these endpoints listed there. It just added the latest endpoint it added, and it forgot that it added two before that. It didn't forget that they were added because it was in the context window, but somehow in the whole documentation flow, it just skipped it.
Okay, so you get there's a need for agents that check agents, and then a human has to recheck that now often.
Yeah, and that's also the route that we are taking with this layer model right now is basically doing the implementation using the layer model in one sense, and then there needs to be a check that it actually did the implementation correctly, and then having that loop between the check agent and the actual implementation agent to see whether it did it correctly. In my opinion, a bit of a waste of tokens, but it's right now the only effective way really to make sure that it did certain things. Because a very clear example is that one of the agents their objective was to do test-driven development. So first write the tests according to the requirements document, and then implement the features and test them every time a feature was completed. Somewhere along the line, it lost the idea that it needs to build tests. So it built the features, but it didn't build the tests anymore. And since back then didn't have an agent that checked that it built the tests, it just was, hey, I did everything I needed to do. I'm done. And then when you review, you are missing half the test. It started out with everything, but then somewhere along the line just started implementing.
Right.
So that's why we moved into it checking with a different set of rules, work of a different agent.
Like a side question, but did you already notice some like sort of rogue behavior of the language models?
No,
Okay.
no.
Last question on this topic of the architecture, the software architecture. Like, how did architecture and software architecture change in under the influence of the language model or the agent-to-agent communications? Because I assume that now as agents are also checking what to do with other agents, this whole machine-to-machine communication, that's not really machine-to-machine, but agent-to-agent communication, I assume that it also really impacts the architecture in a way, maybe also from a security standpoint, but this is probably a very big question to answer, but what's your thought on that? First thoughts?
Uh, I'm not sure what you mean by security implications for an agent-to-agent communication. Can you elaborate a little bit on that?
I assume that you are you need to have these agents that do things like they need access to hosting, to code bases, to maybe design applications, like all these. You have sort of a vault probably that the agent has to access certain tools, and you add agent after agent, which and the agents can communicate with each other, or the one checks the other, and maybe it delivers something to another agent. So is this something that from an architecture standpoint needs to be designed also in a way, or how does that work?
Well, the way they communicate needs to be designed because right now it's more of a synchronous relationship. One agent waits for the other one to output something, and then it continues with the output of another. So there are right now different ways to set up asynchronous communication between agents. So basically, it's just a set of tasks on a queue, and if a set of communication messages on a queue, and whichever agent wants to answer picks it up, it's basically like pops up messaging to that you put something on a stream. You put a message on a stream, and somebody subscribes to it, and then picks it up and does something with it. But there are, I don't know, tens or hundreds of messages there. Whoever wants to pick them up picks them up and do something with it. I don't really think that has implications for security, really. But the security problem that we have with the agents right now is that if you don't give them the proper constraints, they will probably install anything that they will need to do to accomplish the job. And that is where the security implications come in, as we've seen right now, actually, in the past few weeks with these supply chain attacks, is that if an agent doesn't know anything about the outside world in that sense, that what is happening, so it knows I need to install the latest version of a certain package, whether it's impacted or not, it doesn't know. And neither do we actually, but we can set a set of rules that it should either check a public repository with all the exploited packages, or have a set of rules implemented that we don't update to the latest version for a few days. But an autonomous agent that doesn't have these set of rules set out in, let's call it in this sense, architecture, will just get the latest version. And if you did that, for example, for what was it lately? The 10 stack package that is used widely by a lot of developers, then you would have your credentials stolen and you wouldn't even know it because an agent did it. An
Right.
agent ran it, it was installed on your device or in your pipeline by an agent, and it would steal all your environment credentials without you even knowing it. And you would know after the fact, but that is kind of, where the breach already happened.
Like so also like a security agent has a role in this whole environment, I suppose then. So
Exactly.
yeah. And can we then sort of also conclude that the architect of the future is more or less also, is the architect of the future, is that the one that also designs the whole coordination system of the agents and includes then sort of the bill of labor in the sense of like specifying details, not too much, and giving them context? Is that the architect of the future?
I'm not sure. I think there are systems right now that do the communication for you, so you don't really need to recreate that. I think it's more filling in the blanks, but also using your knowledge and your experience to create proper rules that you want to adhere to as much as you want your colleagues to adhere to. But I'm not sure where it's going to move because right now we are really in the beginning stages of this and everyone is having a different opinion. I have a different opinion. I'm using things a different way than my colleagues are as well. But and nobody knows where this is going, right? We all know that it has something and we can use it for something. But I'm not sure if we are ever going to reach the point where we can trust these things fully. Because the thing is that there's so much, it's very easy right now to generate output, but validating the output is one of the hardest things that we need to do. And the more output is generated doesn't make you put it out faster. It just makes you more blind to the things that can, be missed.
In a sense, you draw the same conclusion as the author of the article, that definitely architecture and the architect become more relevant instead of less relevant. So I think,
Right now,
yeah,
yeah, until we can trust every output that is given blindly, not that you can trust the output of a human blindly, but at least there's someone in the driver's seat there. Now you're
taking
basically
responsibility. Yeah.
and taking responsibility. Right now you can say, hey, my agent did it wrong, and the agent's not going to fix it for you. You would need to fix it.
Yeah. Okay. Thank you for your time and insights, Kishan.
Thank you, Floris.